So before we get started with this here, we'll look at number 11. Number 11, evaluate without using a calculator. So here we're looking for a number times itself 6 times to get there. So if we had to take a guess, what number do you think would probably work for this here? 2 would be my guess. And if I wanted to work it out, 2 times 2, so 2 squared would be 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 6. Calculator will tell us also. Because especially when it comes to the test, you're going to be able to use the calculator and plug them in and find it. Yeah. What we're looking at today is continuing on with what we did yesterday. Actually, this first part, we kind of did it already. Because this is, say, let a to the 1 over n be the nth root of a, and let m be a positive integer. So a to the m over n is equal to a to the 1 over m, n to the m is equal to the nth root of a to the n. We actually did that yesterday when we were doing some of the simplifying down. If the integer is negative, well, we just move it from the top of the fraction to the bottom and do the exact same thing. That's really all there is to it. Now, if we wanted to evaluate 16 to the 3/2 by hand, well, as we talked about this yesterday, we could say that this is 16 to the 1/2 to the 3rd. And with one of these here, especially yesterday, we jumped straight from 16 to the 1/2 to what it simplifies to. Because our 1/2 power in radical form is the same as the square root of 16 to the 3rd. Well, the square root of 16 is 4. And now we're taking 4 to the 3rd power. 4 times itself 3 times is 64. Or we could have typed 16 to the 3/2 in the calculator and it would tell us it's 64 too. Questions on this here? Do we kind of feel comfortable with this for the most part? And again, I'm not expecting you all to be able to do this proficiently or have mastery of being able to do this, as long as you understand what we're doing, understand the concept. Because again, if I really wanted to, calculator will do it just nicely. Now our next one, 32 to the negative 3/5. Well, negative 3/5 means we're moving it from the top of the fraction to the bottom. Top of the fraction to the bottom, because we need to make that exponent positive. And we can do the exact same thing we just did. We're going to have 32 to the 1/5 to the 3rd. Now 32 to the 1/5, that's the same as saying we're taking the 5th root of 32. We're trying to find out what number times itself 5 times is 32. And if we're going to have a nice number, it's probably going to be what? Small. Because we saw the other day, the bigger that index, the smaller this is going to get. So if I were to take a guess, I would take a guess saying that the 5th root of 32 is 2. Because 4 cubed, we just saw a minute ago, is 64. So anything bigger than 4 is probably not going to work. And it does work out that 5th root of 2 is 32. And the last thing we have to do is cube it, which tells it is 1/8. And I think if you did it in the graphing calculator, it'll probably tell you it's 0.125. 1/8 math, enter, turn it into a fraction. negative calculator can do it for us. But it's good to have an understanding of this. And if you do end up taking the ACT again, they might ask, especially B, a question like that. But they won't give you, it probably won't give you an answer choice as 1/8. Probably the correct answer that they're going to look for is this here. They're going to stop part way in the middle of it to see, do you know how to simplify it down? And if you forget about how to do this here, that's fine. Plug in all the answer choices, see which one turns into 1/8. All right, we're going to look at two more of these. 64 to the 4/3. Now we can leave it as this here. We don't necessarily have to write it as a radical. We can if we want to. But the 1/3 is telling me what? That I'm looking for what number times itself? 3 times gives me 64, yes? Well, that's the same as the cube root. And the answer is 4. We actually did have that a minute ago, yes? So our answer is 4. I will tell you the bigger the index, so that 1/3, 1/5, 1/6, the bigger that gets, the smaller that number is going to be, because we're looking for a number times itself that many times. So the more we have to multiply it by itself, it's probably going to get smaller. Does that make sense? The only way that we'll have the 6th root of, say, 9, so we're looking for 9 to the 6th, that's 500,000. So they get exponentially bigger the farther out we go. Is that kind of making sense? So now we're looking for 4 to the 4th. 256. And there's different ways to get at that, but again, we can use a calculator to find that. I do find some humor in that. The fact that we break it down this way, okay, I'm going to take the 3rd root of 64, get 4, then cube it, and get 256. We did everything else in the calculator, but put the first thing in. Let's look at B. 16 to the negative 5/4. Well, 1 over 16 to the 5/4. Right, and we can say this is the same as 1 over 16 to the 1/4 to the 5th. Fourth root of 16, 16 to the 1/4. What times itself? 4 times is 16, which would be 2. That's it. Or we could have typed in 16 to the negative 5/4 and it would have given us 1 over 32. If you ever come across one of these, especially the 30XS keeps throwing it out as a decimal, the bottom one, I can figure out what 16, or if it was a bigger number, that is by itself, put it in the bottom of the fraction, and we can figure it out in parts and then put it back together. But either way works. Questions on this here? You ready for this part? Pretty good. All right, let's see what it wants. Evaluate each expression using a calculator. Round your answer to 2 decimal places. Really hard. 9 to the, I think it was 1/5, yes? 1.5518, so 1.55. 12 to the 3/8. 2.54 4th root of 7 cubed. And when you type these in, especially when we have different roots, you don't have to find that x root that first. You can type the number. And that can sometimes help a little bit. So 4th root, you can type 4 second that x root, and it'll throw the 4 up there. If you hit it just before it takes a and s, because since it doesn't have a number in front of it, it's grabbing for the previous answer. So that's why it's saying that there. So type the number, do that there. 4.30. I don't think we need to do more of these. I feel like these are nice. Yes. We have these, but that's all it is. We just type it in the calculator around the 2 spots, because not all of them are going to be nice numbers. There's a lot that aren't. Find the real solutions of these here. So we're going to do some with solving. And we talked about these with the square root method. If I remember right, because the first thing we do is we get the variable with the exponent by itself, take the nth root of both sides, solve for x. Those are the 3 main steps with these here. So 1, we want to get the term with the exponent by itself. We want to get the term with the exponent by itself. Now, this specifically works if we either have one variable and the powers attached to it. Because if we had 4x to the 5th plus 3x to the 3rd, we can't do this because we need one term with a power. Specifically, the variable is only there with the power. So here, we do have that. We have 4x to the 5th equals 128. Is our term with the exponent by itself? No. So we need to divide each side by 4. We need to get it to be by itself. X to the 5th is equal to 32. It's root of both sides. Second step is to take the nth root of both sides. In our term. So we have the 5th, x to the 5th equals 32. So what root are we taking on both sides? 5th. Because the 5th root of x to the 5th is going to be x. We take the 5th root of the other side. 5th root of 32 is 2. Now we need to be careful with roots, taking roots of both sides, because as we saw yesterday, if the index is odd like this is here, we can have one real root, or one real root. So we're fine, yes? When that index, that root we're taking is even, we could have 0, 1, or 2. And for this here, find the real solution. So if it is the no real roots, we have no real solutions. But here, since it's odd, we only have one, and it does work out this here. Now, we will have a step 3 in some cases. Here we don't. Our step 3 is solve for, I'm going to put solve for x. Really, it's solve for the variable. Variable's not always going to be x. But we just need to solve for that variable. Here, we took the 5th root of both sides. X is 2. We are done. If there was something else with x, we'd have to get it on the other side and solve. But that's it. Questions on this here? We ready for the next one? Nope. Well, this one's completely different because we don't have a variable to a power. We have a set of parentheses to a power. But luckily it doesn't matter. Because again, our first step was not get the variable with the exponent by itself, it was get the term, yes? Get the term with the exponent by itself. Here, the term is x minus 3. Is it by itself? Yeah, we already completed step 1. That's why I use term and not variable, because we can still do the same thing. Now we can move to step 2, take the nth root of both sides. We would take the what root? Fourth. Because the fourth root of x minus 3 to the fourth is the fourth root of 21. The fourth root of 21 does not have a nice root. But our index is 4, yes, which is even. So we could have no real roots, one real root, or 2. Since, yes. So if it's odd, we only have 1. Even root. So a is less than 0, no real. A is equal to 0, we have 1 real. And if a is greater than 0, we have 2 real. So since the number inside the root is greater than 0, we have 2 real roots. So we have to add the plus or minus. Are we good with this here? Third step, we need to solve for x. We need to solve for the variable. We have to add 3 to both sides. Now, with this here and on the homework, when it says evaluate rounded 2 decimal places like we did with the calculator, plug it in, give it to me rounded. Solving, still, we're leaving it there. Because we technically still have 2 answers. Our 2 answers are x is equal to 3 plus the 4th root of 21, and x is equal to 3 minus the 4th root of 21. We could plug those in the calculator and get our answers and see what they are. And both of them will work because of the 4th power. Because if it's negative, what we end up plugging in, it'll turn it back to positive, so on and so forth. Questions on what we did here? We feel good with this here? Let's look at the next one. 5x to the third equals 320 is the term with the power by itself. No, so what do we need to do to get it by itself? Divide both sides by 5. So it's telling us x to the third is equal to 64. The term with the power exponent is by itself, so we'll take the nth root of both sides. And our nth root is 3. And since we're taking an odd root of both sides, we only have one solution. Odd roots are nice. Even get a little odd. Questions on this here? We ready for the next one? X plus 3 to the fourth equals 24 is the term with our power by itself. Yeah, so we can move on to step 2, taking the nth root of both sides. And we would take the 4th root. This here, these would cancel. Telling us x plus 3 is equal to the 4th root of 24. Yep, no. There is no 4th root of 24, even if we tried. We try to find 2 a number to the fourth power as a factor of it. There isn't any. But since we're taking an even root of a positive number, we need plus or minus. Now, I will emphasize the fact that not everyone that has a term, set of parentheses, and an even power is going to give us something that doesn't work out. It just happened that it did here. And yes, we do need to solve for x. So we would minus 3 telling us x is equal to negative 3 plus or minus 4th root of 24. Questions on this here? How do we feel about these here? Feel good with these? Do we need to see another example of one of these? That's it. Because the rest are just more solving. If there's one of those that looks like something you want to see, we can go over it. That's it. Now we will have one of those little quizzes, mini quizzes tomorrow over 2 with solving, 3 with simplifying, but same thing.